Welcome back, everyone. We're going to be solving LeetCode 33, search in a rotated sorted array. So they give us an array called nums, which has been rotated an n number of times, and they give us a target value. They want us to find this target value inside of this array, and they want us to write an algorithm to do this in log of n time. So given that statement, we know we are going to have to solve this using some sort of variation of binary search, right? So let's just set that up. So left and right are going to be initialized to 0 and the length of nums minus 1. All right, that'll put our left pointer at 4 and our right pointer at 2 in this case. Now we're going to run a while loop. So while left is less than or equal to right, what are we going to do? We are going to calculate a midpoint. That value is going to be equal to our left pointer plus our right pointer minus our left pointer, and we will floor divide by 2. Now, if the value in our nums array at the midpoint is equal to our target, we can just return our, they want the index, so we can just return m. So we'll set that up. If nums of m is equal to the target, we can just return m. Okay, now this is where we're going to have to get into some sort of variation of the binary search logic, because normally what we would do is say else if nums of our midpoint, if that is less than our target, right, we would move our left pointer ahead of our midpoint by 1. But we can't do that in this case because they have rotated the array. So what we have to do instead is say, okay, well, if nums of our midpoint, if that is greater than or equal to nums of our left pointer, right? So if we take example 1, right, our midpoint initially is going to be 7, and our left pointer is going to be equal to 4. So if this condition is true, then we're going to have to run some sort of condition to check for the midpoint inside of this part of the array, right? So let's write a pass statement here, and if this doesn't, if this conditional doesn't run, then we know the value is going to be in this portion of the array. So that's what this else block is going to be for. So let's fill this out first. So now that we know that our nums at the midpoint is greater than or equal to our left value, then we have to say, is our target value, is that less than our nums of midpoint, right? So if target was 5 in this case, our midpoint is 7, left pointer is 4, and let's just say our target is 5. If that is less than our midpoint and our target value is greater than or equal to our left pointer, then we can say, all right, well, we know it's going to be in this side of the array, so we can decrement our right pointer below our midpoint by 1. Now if this line doesn't execute, then we can just increment our left pointer, right? So left will be equal to m plus 1. Right, now let's run this else conditional. So we'll say, all right, well, if the target value, if that is greater than nums at our midpoint and the target value is less than or equal to nums at our right pointer, what are we going to do? Well, in this case, we are going to increment our left pointer by 1. Otherwise, we'll just decrement our right pointer. And then if we ever exit this while loop, right, we know that we can return -1 from the problem statement. So we will say return -1. So let's get rid of some spaces here and we'll run this. Perfect, we pass all 3 test cases, so we'll submit. Awesome. So time complexity is going to be O of log n, right? That was one of the requirements to solve this problem. Space complexity, we did binary search. We didn't use any extra data structures, so that's going to give us an O of 1 space complexity. All right, that'll do it for LeetCode 33.